Hey everyone, and welcome to today's deep dive. We're going to be tackling a topic that's both exciting and kind of mind-blowing. World Foundation models.
WFMs.
WFMs, exactly. It's like, imagine if you could create a hyper-realistic video game. But instead of you controlling the action, it's all powered by AI.
That's a great way to put it.
So that's essentially what a WFM is, right?
Yeah, essentially a digital twin of our physical world.
And get this. Our source material for this deep dive comes straight from NVIDIA's Cosmos project.
Cutting edge stuff.
They are really pushing the boundaries of what's possible with AI. So today we're going to try to wrap our heads around WFMs, what they are, why they matter, and what NVIDIA is doing with their Cosmos project.
Sounds like a plan.
Okay, so let's start with the basics. Why do we even need these digital worlds in the first place? Can't AI just learn in the real world?
Well, it would be great if it were that simple. But the reality is that training AI, especially for physical tasks, requires a ton of data, like an insane amount of data.
Okay, so like how much data are we talking about here?
Imagine you're trying to teach a robot to walk. You'd need to show it millions of examples of people walking in all sorts of environments.
Okay, yeah, I can see how that would add up quickly.
And even if you could collect all that data in the real world, it wouldn't exactly be safe to have robots just running around learning by trial and error.
Yeah, no robot driver's ed for now.
Exactly.
Yeah.
So that's where WFMs come in.
They provide a safe space for AI to learn and experiment without any real-world risks.
Right. It's like a giant risk-free playground for AI.
I love that analogy.
Right.
So in a WFM, you can create any scenario you can imagine, right?
Pretty much. Anything you can think of, rain, snow, a crowded street, you name it. And because it's all virtual, there's no risk of anyone getting hurt if the AI makes a mistake.
Okay, that makes a lot of sense. So now I'm really curious about this Cosmos project.
Oh, yeah. NVIDIA is doing some really impressive work.
Like how realistic is this digital world they've created?
Well, get this. Cosmos was trained on a data set of 20 million hours of video.
20 million hours. That's more video than I could watch in a lifetime.
It's a mind-boggling amount of data.
But how do they even process that much information?
It all comes down to this process called tokenization.
Tokenization.
Yeah, think of it like compressing those videos into a format that AI can easily understand.
So it's like translating those videos into a language that AI can speak.
Exactly. And NVIDIA's tokenizer is super efficient. It can even handle both still images and videos using the same underlying architecture.
That's wild.
But what's really fascinating is that it's causally aware.
Causally aware. Okay, you're going to have to explain that one.
It means that the tokenizer can only look at past frames in a video when processing it, just like we experience time in the real world.
So it can't peek into the future.
Nope. It's like the AI is experiencing the world unfolding in real time, just like we do.
That's so cool. But why is that so important?
It means the AI is learning to predict what will happen next based on what it's already seen, which is crucial for things like robot control or autonomous driving.
Oh, I see. So it's not just about creating a realistic simulation. It's about teaching AI how to think and act in a way that's compatible with the real world.
You got it.
Okay, so we've got this massive digital world built from millions of hours of video. But how do we actually teach AI to learn and experiment within it?
That's where it gets even more interesting.
Yeah.
And it actually involves two different types of AI models working together.
Two different types. This is getting complicated.
Okay, that right? But stay with me. The first type is called a diffusion model.
Diffusion model.
These are amazing at capturing fine-grained details. Like imagine trying to simulate how light reflects off a moving object. A diffusion model would be perfect for that.
So it's like an AI artist, but instead of painting on canvas, it's painting with data.
You got it. And then you have autoregressive models,
Autoregressive.
which are really good at predicting sequences of events. Think about a ball rolling down a hill. An autoregressive model could accurately predict how the ball will move, bounce, and eventually come to a stop.
Okay, so we have these two master artists, each with their own unique skills.
Yeah.
But how do they actually work together to create a WFM?
Well, that's where NVIDIA's ingenuity comes in. They've developed some pretty clever techniques to make these models work together seamlessly, creating a digital world that's both realistic and incredibly efficient.
Efficient.
Yeah.
Why is that so important?
Well, think about it. The more efficiently these models can process information, the faster the AI can learn and experiment. And that means we can develop new technologies faster, which could have huge implications for fields like robotics, autonomous driving, and more.
This is starting to sound like something straight out of science fiction.
It kind of is.
I mean, we're talking about creating virtual worlds where AI can learn and evolve. The possibilities are endless.
That's what's so exciting about it.
I mean, we could train robots to perform complex tasks in a virtual environment. before ever letting them loose in the real world.
Exactly. It's like a boot camp for robots.
Or think about self-driving cars. We could simulate all sorts of complex traffic scenarios in a WFM, teaching autonomous vehicles how to navigate safely and efficiently.
Without ever putting a human driver at risk.
This is incredible.
It really is a game changer.
But it's not just about practical applications, is it? WFMs could also lead to breakthroughs in scientific research, right?
Absolutely.
We could use WFMs to study complex phenomena that are difficult or impossible to replicate in the real world.
Like the formation of galaxies or the behavior of subatomic particles?
Okay, I'm officially convinced. WFMs are the future. But before we get too carried away, I want to hear more about how NVIDIA built this incredible technology. I mean, 20 million hours of video is a lot to manage. What kind of wizardry did they use to create Cosmos?
Now that's a story for the ages. Let's dive deeper into the technical nuts and bolts of Cosmos after a quick break.
Okay, so we're back and ready to unpack the magic behind NVIDIA's Cosmos.
And believe me, there's a lot to unpack.
20 million hours of video. Where did they even find all that footage?
Well, they didn't exactly have cameras following people around for years. A lot of the data came from publicly available videos online.
So it's like they raided YouTube for science.
You could say that.
But I bet sifting through all those cat videos and cooking tutorials to find the good stuff must have been a challenge.
Oh, absolutely. They had to build a pretty sophisticated system to sort through all those videos and pick out the ones that were actually useful for training a WFM.
So how did they do that?
Well, they developed a special pipeline. This pipeline could analyze each video and determine if it contained the right kind of information.
So what were they looking for?
Videos with lots of movement, different types of environments, and clear examples of cause and effect.
So like a video of a ball bouncing would be good, but a video of a still life painting wouldn't be so helpful.
Exactly. They also had to make sure the video quality was high enough for the AI to learn from.
So no blurry footage or videos with lots of static?
Nope. They needed clear, crisp footage that the AI could really learn from.
It's like they had to curate the ultimate highlight reel of physics in action.
That's a great way to put it.
But once they had all this amazing footage, how did they actually feed it to the AI?
That's where the tokenization process we talked about earlier comes in.
Right, like converting those epic physics demos into AI-readable code.
Exactly.
But wait, didn't you say there are different types of tokenizers?
Good catch. One size doesn't fit all when it comes to tokenization.
So what did NVIDIA do?
They developed a whole family of tokenizers.
Oh, family.
Yeah, each one designed for different types of data and tasks.
So it's like having a toolbox full of different translators,
Exactly.
each with their own special skills.
And choosing the right tokenizer for the job is crucial for making the WFM as efficient and accurate as possible.
Okay, so we've got our data. It's been expertly curated and translated into AI language. Now we're finally ready to build the WFM itself.
Right. But that's where things get really interesting.
Okay, lay it on me.
Building a WFM is kind of like assembling a giant puzzle.
Okay.
Yeah, with each piece representing a different aspect of the physical world.
And those puzzle pieces are the different AI models we talked about earlier, right? The diffusion models and the autoregressive models.
Precisely.
And just like with the tokenizers, there's no one-size-fits-all solution.
Nope. Different AI models have different strengths and weaknesses.
So it's all about finding the right tool for the job.
Exactly.
So tell me more about these AI models.
Well, those diffusion models we talked about are fantastic at capturing the nuances of how light and shadow interact with objects.
So they're like the visual effects artists of the WFM world.
Exactly. They make everything look super realistic.
But those models can be pretty resource intensive, right?
They can be, but NVIDIA has actually done some amazing work on optimizing them, making them much smaller and more efficient without sacrificing their performance.
That's incredible. It's like they figured out how to fit a whole Hollywood studio into a smartphone.
It's pretty impressive.
But what about those autoregressive models? What are they good at?
Those are the masters of prediction. They're really good at understanding how things change over time.
Like predicting how a ball will bounce or how a tree will sway in the wind.
Exactly.
So they're like the physics engines of the WFM,
You got it.
making sure everything moves and behaves realistically.
And by combining these different types of AI models, NVIDIA has created a WFM that's capable of simulating the world in incredible detail.
It sounds like they've built an entire AI ecosystem with all these different parts working together in harmony.
Yeah, it's a pretty remarkable feat of engineering.
Okay, so we have our AI dream team assembled, but how do we actually train them to do their job?
That's a great question.
I can't imagine it's as simple as just showing them a bunch of videos and saying, go learn.
You're right about that. Training a WFM is a complex process.
So what's the secret sauce?
Well, one of the key techniques they use is called progressive training.
Progressive training.
Yeah, it's a lot like how humans learn.
Okay.
I'm intrigued.
You wouldn't try to teach a child calculus before they've learned basic arithmetic, right? Definitely not.
Exactly. So with progressive training, they start by training the AI models on simpler tasks, gradually increasing the complexity as the models learn.
So it's like a training montage for AI,
I like that analogy.
starting with the basics and working their way up to the black bolt level.
And this approach helps the AI models learn more effectively, and it prevents them from getting overwhelmed by too much information too soon.
Makes sense. But it's not just about the visuals, right?
Yeah.
I bet they also use text to help the AI understand what's happening in those videos.
You're absolutely right. Text descriptions are a crucial part of the training process.
So it's like having a narrator explain what's happening in the video.
Exactly. It adds another layer of understanding for the AI.
By combining all of these elements, NVIDIA has created a truly remarkable WFM.
They really have.
It's capable of simulating the world with an unprecedented level of detail and realism.
And that opens up a whole world of possibilities.
Speaking of possibilities, how do we actually put these WFMs to work in the real world?
That's the exciting part. The applications for WFMs are practically limitless.
Okay, hit me with it.
Well, for starters, imagine a world where robots can be trained to perform complex tasks in a safe virtual environment before ever being deployed in the real world.
Like a robot surgeon practicing a delicate procedure in the metaverse before ever picking up a scalpel.
Exactly.
We could drastically reduce the risk of errors and improve the precision of these procedures.
Potentially saving countless lives.
Wow.
And that's just the tip of the iceberg.
There's got to be more.
We could use WFMs to train autonomous vehicles to navigate complex traffic situations, design safer and more efficient factories, even create immersive virtual worlds for education and entertainment.
This is mind-blowing. It feels like we're on the cusp of a new era.
We are.
But as with any powerful technology, there are always potential downsides. What are some of the challenges or risks associated with WFMs?
That's a great question, and it's one we should definitely explore. Let's delve into some of the potential pitfalls of WFMs after a quick break.
All right, so we're back. And we're ready to dive into the potential downsides of WFMs. You know, the other side of the coin.
Yeah, it's important to acknowledge that. Every technology comes with its own set of challenges and risks.
So what are some of the things we need to be mindful of when it comes to WFMs?
Well, one of the biggest concerns is ensuring these incredibly powerful tools are used responsibly.
Okay, so how do we make sure that happens?
It's a complex issue and there's no easy answer, but NVIDIA is taking steps in the right direction.
Oh, so?
They're committed to transparency, making their pre-trained WFMs and the tools they use to build them available to the public.
Interesting. Why is that so important?
It fosters collaboration and accelerates innovation. By sharing these resources, they're encouraging a global community of researchers and developers to work together.
To kind of keep an eye on things.
Exactly. Scrutinize their work and contribute to the development of WFMs.
It's like they're building a global brain trust for the metaverse.
That's a great way to put it.
But transparency alone doesn't solve all the problems, does it?
No, it doesn't.
What else do we need to be thinking about?
Well, another key area of focus is ensuring fairness and preventing bias. We've seen how biased data can lead to AI systems that perpetuate harmful stereotypes or discriminate against certain groups.
Right. We don't want to create a digital world that reflects the same inequalities we see in the real world.
Exactly.
So how do we avoid that?
NVIDIA is using a combination of technical approaches and human oversight to make sure the data used to train these models is as diverse and representative as possible.
So it's not just about letting the algorithms run wild.
Nope.
There's still a crucial role for human judgment.
Absolutely.
So they have teams of experts who are constantly evaluating these WFMs.
Yeah, looking for any signs of bias or unintended consequences.
It's an ongoing process.
It is. It requires constant vigilance.
It sounds like they're really committed to getting this right.
They are
not just throwing this powerful tech out into the world without thinking about the consequences.
They understand the immense potential of WFMs, but they also recognize the responsibility that comes with it.
It's great to see a tech company taking such a thoughtful approach.
And they're not just doing this on their own. They're actively engaging with policymakers, industry leaders, and ethicists to develop guidelines and best practices for the responsible use of WFMs.
So they're trying to build guardrails for the metaverse.
Exact.
Make sure we don't veer off course and end up in some dystopian sci-fi movie.
Yeah, that's a good way to put it.
So where do we go from here? What does the future hold for WFMs?
That's the million-dollar question, isn't it? WFMs are still in their early stages of development, but the possibilities are pretty mind-boggling.
I can already imagine a world where robots are our coworkers, self-driving cars are the norm, and we can explore distant planets from the comfort of our living rooms.
And that's just the beginning. WFMs have the potential to revolutionize countless industries, from healthcare and education to manufacturing and entertainment.
It's both exciting and a little bit daunting. It feels like we're on the cusp of a new era,
We are.
and it's up to all of us to shape it responsibly.
Well said.
I think we've covered a lot of ground today, from the technical intricacies of WFMs to the broader ethical considerations.
It's been a great conversation.
And I hope our listeners now have a better understanding of this fascinating and rapidly evolving field.
Me too.
So to wrap things up, if you're interested in learning more about WFMs and NVIDIA's Cosmos project, we'll be sure to include some links in the show notes. In the meantime, stay curious and keep exploring. The future is out there waiting for us to shape it.
Couldn't have said it better myself.
That's all for today's deep dive. Thanks for listening.